The last example we're going to look at here for volume is working with the volume of cones and spheres. So, for cones, what we can essentially think of this computation as being is something like going from a rectangular solid to a pyramid was, where we're essentially taking the third of a cylinder. So you end up with 1/3 times pi r squared h, 1/3 of the cylinder volume. Meanwhile, for spheres, we can think of the volume of a sphere as being something like a combination of cones and cylinders. So this volume will be 4/3 times pi r cubed. And for these, we're going to look at one brief example where we're supposing we have an ice cream cone that's 5 inches deep with a radius of 1 inch, and a spherical scoop of ice cream is placed in it with a radius of 1 inch, where we want to see if we let the scoop melt entirely, will it overflow out of the cone? So for this, what we need to do is compute each of the volumes and see which is bigger. So first, we're going to look at the volume of the ice cream, where we can use the volume for sphere computation with 4/3 pi and a radius of 1 inch. So that 1 just stays there and we get 4/3 pi, where we can say that pi is approximately 3. So this volume is approximately 4 cubic inches. Meanwhile, for the sphere, so this would be, not the sphere, the cone, that is, we can use that formula, 1/3 pi times the radius, 1 again, squared, multiplied by the height here, which would be 5 inches, where we can use the same sort of idea. 3 is approximately 3 is approximately pi. The 1 just sort of folds into place, and we get that this area would be approximately 5 cubic inches. So the cone should have a bigger volume than the scoop would, and as a result, the answer to our question of overflow would be no.